Okay, hi guys, welcome and hello. So today we're going to finish up chapter 6, which is Chatelier's principle. Okay, so let's look at our learning objectives for today. We will state the Chatelier's principle, simple je. Now we will see how to apply the Chatelier's principle to explain the effect of the following factors on our system that's at equilibrium. So we have concentration of reacting species, the pressure by changing volume, addition of inert gas, temperature and catalyst. Okay. So first of all, the Chatelier's principle. Before this, we learned about determining the equilibrium position, right? Equilibrium position, whether your equilibrium position will shift to the left or right. Left or right by comparing your Q with your K. Okay. So when your Q is equal to your K, that means your system is at equilibrium. When it is not, then your system is not at equilibrium. Okay. What are the disturbances? What are the things that will affect the equilibrium of your system? Okay, the system punya position of equilibrium. The position of your equilibrium can be altered by changing the concentration of your reacting species. Pressure, you can change pressure by changing your volume. Then you can change the temperature. So when you change your temperature, will it change your K? So you can also change by adding inert gas at constant pressure. Okay. What will happen to the position of your equilibrium then? How will it change? Depending on what? That's where Le Chatelier, this guy, comes in. So he proposed a principle, Le Chatelier's principle, and it states that when a system in dynamic equilibrium is disturbed, so it is disturbed by these factors, the system responds to minimize the effect of the disturbance to re-establish the equilibrium. So bila awak punya sistem kena kacau, then your system will reduce that kacau, that disturbance. We'll see later how, until dia dapat dia punya equilibrium balik. Okay? How we will explain, okay, based on the Chatelier's principle. So this is just like a structure on how you can explain when we apply Le Chatelier's principle. So first you're going to state the type of disturbance. So when blah 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 is increase or decrease, okay, when concentration of reactant is increase or decrease, okay, then how the system is going to react to the disturbance. So the system will reduce the effect of disturbance by macam mana? And then you will state the position of your equilibrium. Okay, in order to reduce that disturbance kan. So the equilibrium position will shift forward or backward, or you can say from left to right or from right to left, okay, until a new equilibrium is reached atau until equilibrium is re-established, okay. And then you conclude by stating the concentration of your reactant and your product. Okay, will the concentration increase or decrease? This explanation is what you can use lah. It should be along these sentences, okay? As long as you deliver the point and nak dekat sama, then okay lah, okay? Right. So the first factor is changes in concentration. So when the concentration of your reactant, okay, you have reactant and then you have product. So when the concentration of your reactant is being decreased, so that's your disturbance. Your system will react. Macam mana? To reduce the effect of that disturbance. By forming more products. So that means when the concentration of reactants is increased, your system will want to decrease the concentration of your reactants. How will they do that? They will do that by forming more products. That means you're going to consume more of your reactants to form more products. So, the equilibrium shift macam mana? So, equilibrium position will shift forward or from left to right until a new equilibrium is achieved. So, maksudnya, the equilibrium position will shift to the right. That means the forward reaction. So that you will produce more products and reduce the concentration of your reactant. Okay. In this case, kan, because at constant temperature, the value of K will remain the same. So if you recall, the law of mass action, kan, your Kc is equal to your concentration of product over reactant. So at constant temperature, your K value, even when you change your concentration of product or reactant, your Kc will remain the same. So, changes in concentration will not change the value of your equilibrium constant, okay? Let's say, if we have this kind of reaction, right here, PCl3, Cl2, and then PCl5. Okay, when you add Cl2, what will happen to your reaction? That means your concentration of Cl2 will increase. Okay, when your concentration of Cl2 increases, that means your QC yang sebelum ni is at equilibrium at P's will decrease. So that means your QC will now be lesser than KC. Kan? So, maksudnya, when you add Cl2, the system will reduce the effect of disturbance by decreasing Cl2. Okay, they will decrease Cl2 in order to reach equilibrium again, kan? So that means the equilibrium position will shift from left to right. Okay, left to right. Left to right so that the Cl2, disturbance yang Cl2 ni banyak, you will decrease Cl2. Okay, so decreasing Cl2 by shifting from left to right. So that means the concentration of your PCl5 will increase. Betul? So, concentration of PCl5 will increase, your product and your reactants Cl2 and PCl3 will decrease. Let's say if you remove PCl3, okay, remove PCl3. So if PCl3 is removed atau another case decrease PCl3, so sekarang ni kita cakap pasal remove. Maksudnya PCl3 dah tak ada sekarang ni. Okay. So what will your system do? So your system will try to form PCl3 balik atau increase the concentration of PCl3 tu. What can they do to do that? What they can do is they will increase PCl5, right? So that your reaction will shift to the left. So when the reaction shifts to the left, that means your Cl2 concentration will increase and then you will form PCl3 as well. So the PCl3 punya concentration will increase balik. Okay. So the equilibrium position will shift to the left. Okay. Until your equilibrium is re-established. So then the concentration of your PCl3 and Cl2 will increase and the concentration of your product PCl5 that is being consumed to form PCl3 and Cl2 balik will decrease. Right. How does change in pressure affect your equilibrium position? So, for reactions in the gas phase, so change in pressure is significant only for system with gaseous components. So, kalau ada gas tu, bolehlah ada change in pressure. So, if you increase the pressure at which the reaction is carried out, so when you increase pressure, what will happen? Okay, when you increase pressure, ingat tak pressure is inversely proportional to volume. So, increasing pressure maksudnya you are actually doing that by decreasing the volume of your container. Okay. Kenapa when you decrease the volume of your container, the pressure increases? Kenapa pressure of your gases increases? Because, maksudnya bekas tu makin kecil kan? We will see later that itulah pressure tu increase macam mana. So, what will happen when your pressure increase? Then your position of equilibrium will shift towards the side of equation with fewer gas molecules. Okay. Why? Kenapa nak make fewer number of particles, fewer gas molecules? Why do you want to do that? Because that will reduce the pressure. So when you reduce pressure, that means you are minimizing the disturbance. Sebab your disturbance is increasing pressure kan? So you want to reduce the pressure. How? By shifting towards the side with fewer gas molecules. So you will make lesser number of particles. Okay. Okay, so the pressure of an equilibrium system can be changed by changing the volume of reaction vessel. Okay, so ingatlah itu, I think it's Boyle's law, was it? That pressure is inversely proportional to your volume. Tadi tu, when we talk about pressure and volume, kan? When we change pressure, we will always relate to the number of moles. Okay, so why? When you have a large volume container, right here, large volume, you will have lower pressure. Why do you have lower pressure? Because there are fewer collisions per unit volume. So in order to increase the pressure, you will add more number of molecules so that the pressure will increase. Okay? So kalau smaller volume, then you will have higher pressure because there is a higher collision frequency between your molecules. Okay? Right. So let's say if we have this reaction here, what will happen if we reduce the volume of your container? Okay, if we reduce the volume of container, that means your pressure of your gases will increase. Okay, so since your disturbance is increased in pressure, then how will your system react? Your system will try to reduce the disturbance by apa? Kalau nak decrease pressure ni balik, minimize this disturbance by decreasing or reducing the number of particles. Okay. In order to what? In order to decrease the gas pressure. Okay. What will happen to the equilibrium position? It will shift to the side with fewer number of moles so that the number of moles will decrease. Betul tak? For this reaction, will your equilibrium position shift to the right or left? So let's see. On your left hand side, you have 4 moles. Okay, of gases. On your right hand side, you have 2 moles. Okay, so for this disturbance, according to Chatellier's principle, your system will shift to the side with fewer number of moles. That means to the right. Okay. For this situation, your equilibrium position will shift to the right. Okay. Another case in this situation, if you increase the volume of your container, that means your pressure will be lower. So that's your disturbance. So what will you do? In order to reduce that disturbance, you want to increase balik the pressure, right? So, you will do that by increasing the number of gas particles in order to increase the gas pressure. So, the equilibrium position will shift to the side with more number of moles. So, more number of moles in order to increase the number of gas particles, kan? So the collision frequency will increase so that the gas pressure will increase. That means you will shift towards this side, right? 4 moles. So it will shift to the left. Okay? Or shift backward. Alright? Boleh? So maksudnya bila pressure, look at the number of moles. Which side will you shift towards? Okay. Right. So, ini how you will write the explanation. So, you can read it by yourself. So in this case, when the volume of the system is decreased, that means the pressure is increased, benda sama, the system will reduce the disturbance by reducing the number of gas molecules in order to reduce the gas pressure. So on your left, you have 2 moles of reacting gases and 1 mole on your right, your product side. In order to reduce the disturbance, which is the pressure increase, you want to lower the pressure. That means you want to decrease the number of moles. Okay, how do you decrease the number of moles? Shift to the side with less number of moles. So in this case, there is fewer number of moles on your right side. Therefore, your equilibrium will shift from left to right. Okay, so and then state what will happen when your equilibrium shift from left to right. Okay, so the concentration of your reactants will decrease. Why? So cakap ni PCl3 and Cl2 decrease because it is being consumed kan? When you shift to the right, you are consuming them to form PCl5. So the PCl5 concentration will increase. Boleh? Okay? Right. So this is the opposite situation if your volume is increased. So you can read that by yourself. Okay. What if we have a change in temperature, guys? Okay. The most important thing to remember is that only temperature changes can alter K. Maksudnya, when your temperature change, when your temperature is not constant, then concentration change will alter your equilibrium constant. Okay? The changes in temperature on an equilibrium will depend on 2 of these. Okay? So, this one right here, you can see that the forward reaction is endo and the backward reaction is exo or reverse reaction. So here, forward is exo, reverse is endo. What does these 2 type of reactions tell you? Endo maksudnya, endothermic reaction is when your reaction absorbs heat. So that means right here, for this reaction, the forward reaction is endothermic. Okay. How do you know? Dalam awak punya soalan, dia tak akan tulis pun endo atau exo. Dia akan bagi tahu awak the enthalpy change. Okay. Delta H, your enthalpy change. So, your enthalpy change right here is positive. So, positive indicates that the heat is absorbed for the forward reaction. Okay. Tengok yang atas ni. Forward reaction tu maksudnya endo. Maksudnya when you form NO2 gases, okay, you will absorb heat. Okay. So the forward reaction above is endothermic, right? So ini pula for exo. So tengok dia punya delta H is negative. That means the forward reaction is exothermic. To form NO2, you will release heat. Okay. So maksudnya when you release heat tu, awak punya reaction tu panas lah kan? Let's see generally. How does temperature change affect your equilibrium position and your K? Right here, you have an endothermic reaction for your forward reaction. From A, when you form B, you will absorb heat. Okay, tengok delta H dia Kalau positif tu, maksudnya forward reaction awak endothermic. Okay. Maksudnya exothermic reaction awak ni, yang backward ni maksudnya, okay, kalau exothermic kan backward ke kiri kan. Maksudnya awak akan produce heat bila awak form A. Okay. Awak boleh tulis macam tu to like make it clearer for you. So let's pick a situation, okay. So when the temperature is decreased, contohnya. So this is your disturbance. Temperature decrease. Okay. So then, what will your system do? System will want to increase your temperature kan? Okay. So determine whether the forward reaction is exo or endo by checking their delta H, their enthalpy change. So your forward reaction is endo. Okay, because it is positive. And which reaction will be favoured? Okay. Since your disturbance is decrease in temperature, so your system will want to increase temperature. So kalau dia nak increase temperature, maksudnya dia nak lebih panas atau lebih sejuk. Lebih panas kan? So maksudnya dia nak increase temperature, maksudnya dia will favour exo. True? Right? So, the system will reduce the disturbance by dia akan release heat. Betul? Will favour exo, therefore release heat. So, ini dengan ni dia punya pair. To what? To increase the temperature of the system. Kan? When you decrease the temperature, then your system will want to increase the temperature balik. Okay, to minimize the disturbance. So, the equilibrium position will shift from mana? Which reaction? Yang forward atau back reverse reaction yang exo? Reverse kan? Maksudnya from right to left. Equilibrium is re-established. So, what will happen to the concentration of your reactant and product? So, when you shift to the left, you will form A. So, concentration of A will increase and concentration of B will decrease. Okay. What does that do? When you change the temperature, maksudnya the temperature is not constant kan? So, according to law of mass action, at constant temperature, your equilibrium constant will remain the same. But, then, maksudnya if you change temperature, then your equilibrium constant will change lah kan? So, that means, what will happen to your Kc ni? Dia ada berubah tak? Dia akan berubah kan? So, when you increase ni, decrease ni, maksudnya awak punya Kc, equilibrium constant increase. Okay? Sebab awak change temperature, so Kc boleh berubah. Right? So, when the temperature of the system is increased, right, so this is your disturbance. The endothermic reaction is favourable. Okay, why? Because endothermic means to absorb heat kan? So, system will reduce the effect of disturbance by absorbing the added heat as to reduce the temperature of the system. So, equilibrium position will shift from right to left, which is towards the endothermic reaction, right to the left. Okay. So, ingatlah bila ada change in temperature, you will look at your delta H. Alright. To know whether you will favour exothermic atau endothermic reaction. Okay. So, more NO2 will be consumed. So, maksudnya the concentration of your NO2 will decrease and then your N2O4 will be produced. So, concentration dia akan increase. So, what will happen? The value of Kc and Kp will decrease. So, to know that, awak kena buat awak punya expression. Betul tak? So, awak punya NO2, it will be your product always. Okay? And your N2O4 on your left will be your reactant. Okay? Jangan tukar. Kita tengah cakap pasal shift of equilibrium. So, what happens to your Kc? So, your Kc, when your NO2 decrease, therefore your Kc will decrease as well. Okay? Alright, this is the opposite situation. So, ni kalau awak decrease the temperature. When you decrease the temperature, this is your disturbance. Okay, disturbance. Your system will want to, system akan increase the temperature. Okay, how to increase temperature? Let's look at the delta H. So, delta H means forward reaction is exothermic. So, endothermic reaction is your reverse reaction. How to increase the temperature of your system? by releasing more heat kan. So that means your equilibrium position will shift from left to right. Because exothermic akan release heat. So lebih panas lah sistem awak. Betul tak? So kita nak reduce the disturbance. So shift from left to right. That means the concentration of NO2 will increase and N2O4 will decrease. Therefore, your Kc will increase. Okay? Buat expression kalau nak tengok. Addition of inert gas. There can be two different situations. Okay? When you add inert gas. So, inert gas tu apa? Inert gas atau noble gases. Okay? Gas yang won't react with your other gases. It won't react with other gases. Okay? Inert. So, at constant volume, if you add in a gas, then the total number of gas molecules will increase. Okay? Lebih banyak awak punya number of gases. So, what happens then? At constant volume, maksudnya your pressure can change. Okay? Pressure of gases can change. So, the total pressure of your equilibrium system will increase. Okay, so the volume and the quantity of reacting species remain constant. Okay, even when you add your inert gas, since your volume is constant and your pressure can change, that means the partial pressure of each of your gases, okay, your reacting gases, your reacting species will remain constant. To understand this at constant volume ni is that pressure of your reactant gases and pressure of your product gases, partial pressure dia akan remain constant. Okay, tak berubah. Okay, therefore, the position of equilibrium and equilibrium constant will not change. So, maksudnya, there will be no shift, okay, of equilibrium position. And then your K will be constant. Maksudnya tak ada perubahan. Okay. So, maksudnya ingat at constant volume. Okay, because your pressure can change. Jadi, even bila awak tambah awak punya inert gas, kan, total pressure tu increase kan? Boleh increase. So, bila total pressure boleh increase, maksudnya awak punya partial pressure untuk each gas akan remain the same. Maksudnya bila buat KP kan? KP kan depends on your partial pressure of product gases and partial pressure of your reactant gases kan? So, since your partial pressure remains the same, inert gas tak masuk dalam expression awak. Since your partial pressure remains the same, therefore your Kp will remain the same. So, there's no change in Kp, therefore tak adalah nak shift mana-mana, okay? So, itu constant volume, okay? Ingat For constant pressure pula. So, constant pressure maksudnya your volume can change. Volume can change. But, pressure cannot, okay? So, this has the same effect as increase in volume, decrease in pressure. So, kalau increase in volume, then pressure decrease. Ingat tak? Ball's law. So, adding inert gas to the system at a constant external pressure increases the volume of container. Since you are keeping the pressure the same and your volume can change, that means bila you add more gases, then the volume of your container will increase. Okay? Pressure remains constant kan? So that means the partial pressure of each gas in the system will decrease. Okay, kalau macam tu maksudnya awak punya KP kan? Partial pressure of your product gases dengan partial pressure of your reactant gases, when they decrease, then your Kp will change lah. Betul tak? So that means there will be an equilibrium shift to the side with more moles of gas to increase the pressure. Okay? So bila partial pressure of each gas decrease, that's your disturbance. Betul? That's the effect of your disturbance, which is adding inert gas ni. So how do we reduce this? So we reduce this effect by increasing the pressure again. Betul tak? Okay, how? Untuk ingat, kalau pressure, awak akan tengok the number of moles. So you will shift towards the side with more number of moles, so that you make more number of moles of gases to increase the pressure again. Okay? Right. So this is a visualization of what it means to add inert gases at constant pressure. So that's your reaction, and this is your volume of container. So your volume of container can change, kan? So right now we have gas A and gas B. So this is the partial pressure, and this is your total partial pressure. Okay, constant pressure kan, maksudnya PT ni tak akan berubah. So let's say it's 10 atm and 10 atm for your partial pressure of each gas. So when you add helium gas and inert gas, what will happen to your volume of container? Your volume will increase to maintain the pressure. So total partial pressure is still the same, but your volume will increase. Okay? So volume dia dah jadi 10 liter, 10 liters or 10 dm cube. So now, since the total partial pressure is still 20 atm, that means what will happen to the partial pressure of your gas A and B? That means gas A and B, their partial pressure will decrease. Betul tak? Kan? Okay, boleh faham kan? So when the partial pressure decrease, how do you minimize this effect of disturbance? This disturbance when your partial pressure decrease. You will have to increase the pressure by producing more moles of gases. Okay? So in this case, your equilibrium will shift to mana? Right ke left? Tengok sini. Tengok sini. Your reactant ni. So on the left, you have 2 moles. On your right, you have 1 mole. So, what does it mean? Awak akan shift to right ke left? More moles. You akan shift to the left. Okay? Right? Because you want to produce more moles of gases to increase the pressure again. Alright? To re-establish equilibrium. Therefore, what happens to the concentration of A? Concentration of A will increase lah kan? Because you are going to form more A's. And concentration of B, what will happen? Decrease lah kan? Because you are consuming it. Okay, when you shift to the left. Okay? So, how about catalyst? Have you heard of catalyst before? It speeds up the reaction by providing an alternative pathway which has a lower activation energy. Okay. So, it will increase the forward and reverse rates to the same extent. So maksudnya, your rate of forward reaction will always be the same with the rate of your reverse reaction because dia tak pilih kasih. It won't be lebih lajukan forward daripada reverse. Okay? Sama je. Okay. Therefore, it will shorten the time taken to reach equilibrium. So, catalyst tu akan cepatkan reaction awak je lah. Okay? So, that means the presence of your catalyst will not change the composition of your equilibrium mixture. Maksudnya, concentration of your reactant and product tu will still remain the same. Okay? Dia laju je. It will still remain the same. Okay? So, catalyst does not affect the position of your equilibrium. Kenapa? Kenapa dia tak affect? Dilajukan je kan? So, rate of forward dengan rate of reverse awak still sama. So, your Q and K Q and K basically remains still sama. Awak takkan shift to right atau awak takkan shift to left. Sebab dia tak kacau pun awak punya concentration, temperature, apa lagi itu semua. So, finally, catalyst does not affect the value of equilibrium constant K. Right? So, since it does not change the composition of your equilibrium mixture, your reactant and product tu, so your K pun is not affected, okay? So, your concentration of product over concentration of reactant. It's not affected. So, basically, catalyst does not affect the position of your equilibrium, so no shift, okay, and it does not affect your K, no effect. So to summarize, we are going to see a few of these questions, right? So consider the following equilibrium system. Let's see. For this reaction, okay? So, you can see that it is an exothermic reaction. So, determine in which direction will the reaction shift. So, dia nak tahu direction. Shift right, shift left. Macam mana? So, the effect on the equilibrium concentration, maksudnya concentration of your product and reactant, and the change in value of K. So, is K affected or not? Right? So, if we add oxygen to our system, okay, this is your disturbance. What will happen? Your system will want to decrease balik the disturbance by, minimize the disturbance by decreasing the concentration of oxygen. Okay, maksudnya, what will your system do? It will shift to the right. Kan? Nak decrease balik kan? So, when you shift to the right, what will happen to the concentrations of your product and reactant? So, mention lah. When you shift to the right, your product concentration will increase. Cakap N2 dengan H2O. So, your reactants, NH3 dengan oxygen will decrease. Okay? So, it will shift to the right until equilibrium is re-established. Okay. Will there be a change in the value of K? You are changing concentrations. Are you changing the temperature? No, right? So, therefore, your K remains unchanged. Okay. Second, you're removing NH3. Removing NH3. Hilang terus NH3 ni. So, when you remove NH3, that means your system will want to form balik NH3. Right? So, the concentration will increase. Okay, will form and increase. So, what will happen? How will your system respond to this disturbance? They will shift to the left. Betul tak? So, they will shift to the left by decreasing the concentration of your products, which is water and N2, and increasing the concentration of oxygen, and NH3 will form again and increase in concentration. Betul? Boleh kan? Okay. So, will there be a change in K? Are you changing the temperature? No, right? So, K will be constant as well, okay? Okay, boleh? So, third, when you increase the temperature, this is your disturbance. That means your system will want to, system nak apa? System will want to decrease the temperature, betul? So, in order to decrease the temperature, your system will favour what kind of reaction? What type of reaction? Yang absorb heat kan? Absorb heat tu yang mana? Endothermic reaction. Okay. So let's see. For your reversible reaction atas ni, your forward reaction is exo ke endothermic? Tengok delta H. It's minus 1531 kilojoule, right? So minus means that your forward reaction is exothermic. And your reverse reaction to the left is endothermic. To reduce this disturbance, your system will shift to the left. So shift to the left. Tulis elok-elok lah awak. Saya tulis macam ni je. Okay, shift to the left. System will re-establish equilibrium, okay? Okay. So, awak change in temperature ni. Will your value of K change? Will it change? Yes, okay. K will change. Okay, macam nak tahu? When you shift to the left, towards endo reaction, kan? What will happen to the concentration? Concentration of your reactants H2O dengan N2 tu akan, your products will decrease, right? And your reactant will increase, right? So, buatlah KC. Okay, awak buat elok-elok Saya just tulis produk dengan reactant ni sebab yelah nak, just nak tunjuk awak tulislah betul-betul. So, bila awak punya produk decrease, that means your KC will decrease, okay? So, the value of K will decrease when you increase the temperature of this reaction. Okay, ni jawapan dia. Okay. Alright, yang first tu ni saya rasa awak boleh lah baca sendiri, ya. Kita tengok yang C, D, E and seterusnya. So, for this reaction, using the Chatelier's principle, I explain the shift in equilibrium position, if any, of the reaction. Shift in equilibrium position. So, if a catalyst is added, okay guys, what does the catalyst do? It speeds up reaction, right? Does it affect the equilibrium constant? Does it affect the shift of equilibrium position? Does it affect the equilibrium mixture? Does it affect? No. Okay. So that means when a catalyst is added, there will be no net change in QC and KC. Okay. Right. Next. What if your C2H6 is removed? If your C2H6 is removed from the system, what will happen? How to reduce this disturbance? Your equilibrium position will shift up, will shift to the left. Betul tak? It will shift to the left, kan? Shift to the left. Because you want to decrease the concentration of H2 and C2H4 in order to form your C2H6. Alright? Betul? To what? Why do they do that? To re-establish equilibrium. Betul? Right. So, what will happen to the concentration? So, cakap lah, concentration of C2H6 when you shift to the left will increase and the concentration of C2H4 and H2 will decrease. Okay? Senang je lah 6.3 ni kan? Kalau cakap pasal pressure dengan volume je confusing sikit. Right? Dengan temperature. Sikit lah, sikit je. So, the volume of container is increased. Okay. Bila kita cakap pasal volume, maksudnya kita akan relate to pressure juga. So, when volume of container is increased, that means your disturbance lagi satu is pressure decrease. Okay. How will your system respond to this disturbance? It will respond by increasing the pressure. Betul? What will increase your pressure? By increasing the number of moles. Betul? So, that means for this disturbance, your system will shift to the side with more number of moles. So, right here we can see on your left, Dekat reactant, you have 1 mole only. On your right, you have 2 moles. The equilibrium position will shift to the right, to the side with more number of moles in order to produce more moles of gases. So when you have more moles of gases, therefore the pressure will increase. So when the pressure increase, that means you're reducing the disturbance. Okay, you shift to the right to re-establish your equilibrium. Okay, boleh? So, macam mana? So, the concentration cakap juga concentration of your C2H6. When you shift to the right, apa jadi? Will decrease lah kan? Concentration of C2H4 dengan H2, Gwenner guys, will increase. Okay? The pressure is increased. Maksudnya apa tu? How do you increase your pressure? By reducing your volume kan? So, when the pressure increase, that means your system will want to reduce the pressure pula. So, how to reduce the pressure? Maksudnya you want to shift to the side with fewer number of moles. So, yang ni 1 mole, yang ni 2 mole. Maksudnya, awak punya equilibrium position will shift to the left. Betul tak? So that you make fewer number of moles of gases. So that the pressure can be reduced to re-establish equilibrium. Okay, saya dah cakap banyak kali dah. Lepas cakap lah punya concentration. Okay. When an inert gas is added at constant pressure. Okay, constant pressure maksudnya volume can change, right? So, how does it change? Your volume will increase. Okay. So, when your volume will increase, maksudnya your total pressure remains the same. So, when your total pressure remains the same, the partial pressure of your C2H6, C2H4, notice lah, macam tu, dengan H2 will decrease. Okay. This is the effect of your disturbance. The partial pressure of your gases decrease. What will you do? How will your system respond to this disturbance? It will try to increase the pressure, right? How to increase the pressure? Shift to the side with more number of moles. Okay, to produce more number of moles of gases. So which side is that? More number of moles to the right. Okay. Boleh? Okay. So, sambunglah ayat yang lain. Okay. When you add inert gas at constant volume pula. Constant volume. So, when you add inert gas at constant volume, that means your pressure can change. If your pressure can change, that means your partial pressure of C2H6, C2H4 and H2, the partial pressure and volume remains the same, remains constant. So that means, will there be any change in your Kp? No, right? Sebab partial pressure semua sama. So Kp tak berubah. Will there be any shift of in equilibrium? Tak ada kan? So that means your equilibrium position does not change. Okay? Boleh? Alright? Okay. So pressure can change ni apa? Total pressure lah. Bila total pressure can change, maksudnya partial pressure awak remains constant. Okay? Alright. So that's the end of 6.3 Le Chatelier's principle. Clap. Pakso. So make your own notes. I don't know lah awak sempat ke tak buat kan. So I hope you understand. So attempt tutorial questions macam biasa to see if you understand the concept. Okay. So thank you guys. That's all from me.